Do you know what is
Yes,
Coulomb's
sir.
law?
Yes, sir.
What is it?
The electrostatic force of repulsion or attraction between 2 point charges is directly proportional to the product of the magnitude of the charges and is inversely proportional to the square of the distance between the two charges and acting on the line joining the two charges.
Yes, absolutely correct. So I'm not going to discuss whole thing, okay? That Coulomb experimented this and found out that force is directly proportional to the product of charge and inversely proportional to 1 upon r square. So F is given by k q1 q2 by r square, and the value of k is given by 9 into 10 raised to 9. We can also write it as 1 by 4 pi epsilon naught, where epsilon naught is the permittivity of vacuum and its value is what? 8.85 into
8.854 into 10 to the power minus 34
minus 12
Newton to the power, sorry, minus 12. Yes, yes, sir.
coulomb square per
Per
newton per
Newton.
meter square. Okay, so this is the Coulomb's law. Now let's do one question here. Okay, let's say there are two charges, 1 coulomb charges. One is positive, another one is negative, and they are separated 1 meter apart. Okay, you need to find the force acting on both of them. Okay, mutual force we need to find out. So Coulomb force is given by kq1 q2 upon r square. Here k is 9 into 10 raised to 9, of course, minus 1 into plus 1, and r square is 1, so it will be minus 9 into 10 raised to 9 coulomb. It will be Newton, right? So that will be the answer, easy one, right? Now let's talk about
Yes,
Coulomb's law in a vector form. Coulomb's law in a vector form. Okay, so let's say there are two charges, okay, which are situated. Let's say this is q1 and this is q2, and the distance from the origin is, let's say, this one is r2 vector and this one is r1 vector. Now you do realize that what is the, do you know how to add the vectors? Hmm?
vector addition. Vector addition.
So let's say there is one vector a and there is second, this is the second one. Okay, if their tail and head is touching each other, that means the resultant vector will be the addition of both of them. Okay, understood?
Yes, sir.
So in this case, this distance will be what? Let's name it
The sum of the.
r21. Okay, which can be
Yes,
given
sir.
by r2 vector minus r1 vector. Okay, because
Yes,
here
sir.
the two heads are touching each other. Okay, so if you want did you understood this, how we got this r21?
Yes, sir.
Okay, this r1 and this r21 will add up, r1 plus r21 will be equal to what, this r2, by this law, right? So that we can write it as r2 minus r1, right? So both the charges will, I mean, there will be two forces because the Coulombic force is mutual one, right? So here it will be F21 and here it will be F12. What does this mean, F12? force on 2 with respect to 1. Sorry, force on second charge due to first one. Understood?
Could you repeat it again?
I okay, okay. Force on first charge due to second one. Force on second charge. Sorry. Again, mistakenly. Sorry. Force on first charge due to second one. Understood?
Yes, sir.
Okay, so the relation will be F12 is equal to minus F21 since they are both uh, anti-parallel to each other. Okay, as you can see here from the figure. What does this mean? F21 force on second charge due to first one. Okay, which is here. Okay, so how do we write this
Yes, sir.
F12? So F12 can be given as K Q1 Q2 upon which distance it will be? It will be R12 square multiplied by the unit vector of R12. Understood? This is called a unit vector. It represents the direction. Okay, so F12 is in this direction. That means R12 we can represent this direction as R1. Understood?
Yes, sir.
Okay, so this was the representation of force. Okay, in vector form. Now forces between multiple charges. Forces due to multiple charges. Sorry. So let's take a test charge. Okay, let's name it Q. And there are, let's name it Q1. There are other charges also in the surrounding. Q2, Q3, Q4. Too many charges. Okay. So they all will exert force on this charge, right? The fifth one will repel this charge in this direction. We are taking all the charges as positive. Okay, we can also take negative charges, but it's okay right now. So this Q4 will exert force in this direction, Q2 will exert force in this direction. Okay, so how to find the resultant force on this charge Q1, our test charge Q? So for that's why I've changed the heading from forces between multiple charges to forces due to multiple charges. Okay, so simply it will be sum of all the forces on the test charge. Okay, F14 and so on. We know that how we can write this F12. It will be KQ1 Q2 upon R12 square, right?
Yes,
Dot
sir.
R12 cap. Similarly, how to write this force? It will be KQ1 Q3 upon R13 square into R13 cap and so on. We can take this K common. Okay, KQ1 common. So it will be Q2 R12 cap upon R12 square plus Q3 R13 cap upon R13 square and so on. So we can represent this in the form of summation, that KQ1 summation I is equal to 2 to n QI R1I cap upon R1I square. Okay, what is this I? You can
Yes,
put
sir.
many values from 2 to infinity. Okay, if you place here 3, it will be q3 r13 upon r13 square, which is our second, as you can see. Understood? Now write it down,
Yes, sir.
both the concepts. Done?
No, sir. So done for this part.
Done?
Yes, sir.
Okay. Now there is one interesting question that we are going to do here. The question says two fixed charges plus 4 coulomb and plus q are at a distance 3 meter apart. At what point between the charges a third charge plus q must be placed to keep it in equilibrium? You want to try this one?
Yes, sir.
Try it. Done?
No, sir, I'm still doing.
Okay. Yeah. Done? Hello.
Sir, I'm doing the quadratic equation.
This question is very easy. You are
Yes,
taking too
sir.
much time. Let me do it for you. So there are two charges plus 4q and q. Okay, and there is this third charge. We are going to place here. Let's say this distance is x, and since it is 3 meter apart, we can take this distance as 3 minus x, right? So we know that they must stay in equilibrium, right? So the force on this charge due to this 4q must be equal to the force on this q charge due to this small q charge. Okay, so that means force due to this 4kq charge will be, let's name it as F1. So F1 will be k4q into q upon x square, which is basically 4kq square upon x square. And force due to this small q charge, let's name it as F2. So F2 will be kq square upon 3 minus x square. Okay, we are going to compare both the forces. So F1 will be equal to F2, okay, because of the equilibrium. So it will be 4kq square upon x square is equal to kq square upon 3 minus x square. K K Q Q will get cancelled out. We will get 4 by x square is equal to 1 by 3 minus x square. Okay, we are going to apply both this side under root. Okay, we can do that, right? So it will be 2 by x is equal to 1 by 3 minus x. Understood? Now just multiply this 3 minus x with this 2. It will be 2 3 minus x is equal to x. That means 6 minus 2x is equal to x. So 6 will be equal to 3x. That means x will be equal to 2. So the answer will be 2 meter and it will be 1 meter. Understood?
Yes, sir.
Okay, there is one trick here also. Do you want me to discuss this trick?
Yes,
So,
sir.
shortcut method. What is the shortcut? There is some one important condition that if q1 q2 is greater than 0, that means if both the charge are positive or both the charge are negative, then the distance will be r0, which is given distance. Okay, in our case it is 3 meter, so it will be r0 upon under root q2 by q1 plus 1. And if q1 q2 is less than 0, x will be r0 upon under root q2 by q1 minus. Okay, let's apply this formula in our given problem. So it will be 3 by under root. What was q2? It was
Point.
small q. And what is q1? It was
Yeah.
4q.
You.
So it will be 3 by 1 by 2 plus 1, right? So 3
Yes, sir. It will
by
be
3 into 2, it will be 2 meter. Answer.
Yes, sir.
Write it down.
Yes, sir.
Okay, let me give you one question in homework. Okay, this question you need to do with the trick. The question is, a charge q1 is equal to 1 coulomb and q2 is equal to minus 4 coulomb are fixed at a separation of 1 meter. Where should you place the third charge, small q, so that the entire system is in equilibrium? Write it down, do this question in homework.
Yes, sir.
Done? Okay. Now comes the important quantity, which is known as electric field. So what is electric field? Electric field is nothing. Electric field is the vector way of representing the space around a charge, which helps in calculating the force of one charge on the other. Okay, it is the vector representation of electric force on a unit charge. Okay, let's say there is one charge. Okay, and there is this our small q, our test charge. So let's say that the value of this test charge is 1. Okay, 1 unit. So the force on this small q charge due to this capital Q will be what? F will be k q1 q2 upon r square, right? Since here q2 is 1 coulomb, so it will be Okay, F is KQ1 Q2 upon R square. But the definition is electric field is what? Force per unit charge. Okay, electric field is force per unit charge or force on a unit charge. That means F by Q is our electric field. So this is the formula for the electric field. Understood? And what charge is this? This is the source charge. Okay, this charge is a source charge. And what is the physical significance of electric field? If you remove this charge, so whatever remains in this vicinity of charge is our field. This is the field up to which a charge can exert a force on another charge. Understood?
Yes, sir.
Write it down.
Yes, sir. Fine.
Okay. And one thing to understand here is that this test charge is so small. Okay, this test charge is so small. Yes, it is having its own electric field, but since it's too small, it cannot exert a enlarged force on this capital Q charge. Okay, it cannot move this charge toward itself. Only the bigger one can do such thing, or it can apply a uh, enlarged electric force. Okay, so that's why we have taken this test charge who have these properties, like it is so small, it doesn't have any significant electric field. Okay, so that our calculations becomes very easier. Okay, and one thing, that test charge have a spherical symmetry. That means if there is this test charge, okay, so at the same distance from this charge, electric field will be same. Okay, let's say E1, this is E2, this is E3, all will be same at the same, from the same distance. Okay, that's why it has a spherical symmetry. Understood?
Yes, sir.
Okay, so from this we can write F by Q is equal to E, right? That means we can represent force in terms of electric field as F is equal to QE, or electric field as F by Q. We can derive the SI unit of electric field from here, which is Newton per Coulomb. Done?
Yes, sir.
Let's take one question. before going further, that they calculate the magnitude of electric field which can just suspend a deuteron of mass 3.2 into 10 raised to minus 27 kilogram in air. You think you can do this? Do you
I
understood the
don't think
question?
we have to find the electric field of the deuteron, but then they have only given us mass. They have not given us any charge. They have only given mass.
Electric field. We need to find the electric field which can sustain, which can levitate the deuterium in the air. This is the deuterium. We need to find this electric field which can
Yes.
levitate the deuterium.
So we could do number of. I'm not sure about it, so my method.
Okay,
Seen
so
it
if
before.
you want to levitate the
But I'm
deuterium,
not sure about it. I think I'm not sure about how to solve it. But then I do have an idea of what to do.
what to do?
We have to first find Q. First Q is required. Q we can
It,
get is 3.2
for
into 10 to the
deuteron, it
power
is
minus 27.
for deuteron it is 1.6 into minus 10 raised to minus 19 coulomb. Okay.
Yes, sir. But then so Q is there, but then for this one deuteron, right? So 2 mass is equal to 2.
So remember, there is also gravity is acting on the deuteron, right? So its weight force is downward, which is mg. We need to
Yes, sir.
find this electric force. If it equals the weight, then it can levitate in the air. That means
Okay.
Fe must be equal to mg. And what is Fe? It is QE. And we need to find electric field. So from here,
Yes.
it is minus 27, and we are taking the acceleration due to gravity as 9.8, and charge as, it will give us roughly how much? 16
19.6.
to the 32, right?
Yes, sir. Should be
So,
told.
so it will be 19.6 into 10 raised to minus 8 Newton per coulomb.
So we don't need to find like Q is equal to N by N into E into E. So then N would be number of
No, no,
moles
no,
into
no, no,
moles
no,
into 6.6.
no, no, no.
So in the question, they won't give us the charge of deuteron and all, right?
So we
Like
are,
suppose will they give us like the
whenever
value of
they
Q and all?
whenever they ask such a question, for the deuteron, always take charge as 1.6 into 10 raised to minus 90.
Yes, sir. But if
What
it's
is a
any other metal,
deuteron?
like for example, say iron,
That means what is a deuteron? So for your knowledge,
deuteron is hydrogen with two.
what?
Hydrogen with an atomic mass of 2.
A deuteron
Oh no, it's not.
is an isotope of hydrogen consisting basically one proton and one neutron. That's it. There is no electron. Okay?
Okay.
And since neutron is neutral, we end up with the
2.6.
charge of proton, which is Q, which is 1.6 into
Oh,
10 raised to minus 19.
okay, sir.
Write it down.
Okay, sir. Yes, sir. Sir, there was a question in one of the books I checked, like a question similar to this, but they have given iron. For
Iron.
iron they have given. So in that case, we have to do n number of moles into
Yes,
6.023.
yes, yes.
In that case, we have to.
Yes, yes. Absolutely.
But in this case, if they give deuteron, then the next isotope, if they give, then in that case also Q will not be equal to
Yes,
1.6, right?
yes. Of course, of course. That's why I said that if they ask you if the question mentions a deuteron, that means the charge is 1.6 into 10 raised to minus 19. Same as proton. Done?
Yes, sir.
Okay. Let's talk about electric field due to a system of charges. Due to system of charges. So let's say there are these three charges Q1, Q2, and Q3. So we need to find the electric field at this point. Let's name it as O. Okay. Let's take this distance as R1. Okay. Let's take this distance as, let's name it as P. So it will be R1P. It will be R2P. It will be R3P. Okay. And this is Qn, nth charge particle, which is Rnp. So we know that, let's say this is the charge. Okay. So at r distance, if you want to find the electric field at this point, it will simply be kq upon r square, right? So same way, due to this q1, electric field at point P will be kq1 upon r1p square, right?
Yes, sir.
r1p cap. Due to this one, kq2 upon r2p square into r2p, and so on. Okay, basically there is sums up. Okay, so we get, if you take this k common, which is 1 by 4 pi epsilon naught, we can write this whole expression as summation of I is equal to 1 to n qi upon rpi square into rpi cap. Understood?
Yes, sir.
Write it down.
Yes, sir.
Okay, let's take one example. 2 point charges, 2 microcoulomb and 8 microcoulomb, are placed 12 centimeter apart. Find the position of the point where the electric field will be zero. These type of questions are most favorite. Okay, these type of questions can get asked in board exam, and this question appeared many times in the board exam. So the situation here is there are two charges, 2 microcoulomb and 8 microcoulomb. Let's take our point P here. Okay, let's say here the electric field is zero. Okay, let's take this distance as x, and this distance will be 12 minus x. Why? Because the distance is 12 centimeter. So since here the electric field vanishes, that means electric field due to this charge and electric field due to this charge must be equal. So electric field due to this charge is kq upon x square is equal to electric field due to this charge, which will be kq2 upon 12 minus x square. This k will get cancelled out, and we are plugging this 2 microcoulomb and 8 microcoulomb value. It will be 2 by x square is equal to 8 by 12 minus x whole square. Understood?
Yes,
So
sir.
2 4s are 8. That means 1 by x square is equal to 4 by 12 minus x square. Applying roots on both these sides, we will get 1 by x is equal to 2 by 12 minus x, right? So it will be 12 minus x is equal to 2x. That means 12 is equal to 3x. That means x will be equal to 4 centimeter. And if this is 4 centimeter, this will be 8 centimeter. So this is the answer. Done?
Yes, sir, done.
Okay. I'm giving you one question for the homework, okay? The question is, four charges are placed on corners of a square having a side 10 centimeter. If Q is 1 microcoulomb, then what will be electric field intensity at the center of the square? Okay, so the figure is like this way. Here is minus 2 q coulomb, here is q coulomb, this is minus q, this is plus 2. Write it down.
Sir, and the charge in the middle is how what, sir?
Four charges are placed on corner of a square. You need to find the electric field
Yes,
at the
sir.
center. There is no charge.
Yes, sir, that's what I'm asking, sir. No
No, no,
charge.
no charge. Of course, it does not require a charge to find the electric field due to a charge. Remember?
Sir, is it zero?
No. Did you write it down? Wrote it down?
Yes, sir, I wrote it down.
Okay. Now, one statement I need you to remember. The statement is, okay, please write this on top of your textbook. If a charge Q is placed at each vertex of a regular polygon, the net electric field at its center is zero. Okay? Regular polygon means an equilateral triangle, a square,
Yes, sir.
a pentagon. Okay?
Yes, sir, but all the charges should be equal.
Yes.